Okay, good morning or good afternoon, whatever class you're in here. What we're going to do today is we're going to take this data that we collected in fox and rabbit game last Friday, and we're going to graph it. And after we're done graphing this information, we're going to interpret the graphs and try to kind of figure out what happened to our rabbits and foxes and resources on Friday. All right, so this is a little bit different today. We're going to be making a line graph for the first time this year, so I'm going to kind of walk you through some of the steps on how to develop a line graph. It's not really too much different from the bar graphs that we're used to making in science. So take a look at your data, look at your rabbit population data, your environment data. Remember, those are the number of resources that were available in each generation, and then the number of foxes. Okay, and in your notebook, I want you to turn to the first page that looks like this. This is the page that has questions about the rabbits. When you're making a line graph, you want to set up your axes the same way. Remember that the vertical axis is called the y-axis. The horizontal axis is called the x-axis. Right, that doesn't change. And remember that when we're setting up a graph, that you want to put the dependent variable on the y-axis. Put that back up here. And remember that the vertical line here can be used to make a V. And down here at the bottom, that this horizontal line can be used to make an I. So we want to put our IV on the x-axis down here, and our dV on the y-axis. Okay? So in this case, what we were recording, our dependent variable, is the rabbit population. Okay? And what we were changing over time was simply the generations of rabbits. So I'm going to erase my other labels here, and I'm going to put generation down here. Okay. On a line graph, this point still represents 0, so we're going to label that 0. Okay. And we're going to start by labeling the different generations. Look at your data. Some classes had more generation than others. Let's take a look here at this one here. Okay, it looks like this class had 14 generations down here at the bottom. So let's go ahead and start numbering off. We're going to put these numbers on the line. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 13, and 14 generations. Okay. And then what I have to look at is I have to look at the rabbit population here. My highest rabbit population was 20. So let's see if I have enough space. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, I have enough space on my y-axis to do ones as my scale, so I'm going to label these with 1, 2, 3. Okay, notice I'm trying to put those numbers on the line there. My smartboard didn't always agree with me there. But I'm trying to put the number on the line or next to the line. All right, then I have to look at my data and I have to start plotting. And this, instead of being bars, we're going to plot points. So in generation 1, there were 2 rabbits. So I'm going to go to my first generation here. Generation 1 had 2 rabbits. I'm going to look at my next generation. Generation 2 had 4 rabbits. So I go to generation 2 and I find that there's 4 rabbits. Okay, what I want you to do is I want you to go through, well, let's do one more here. Generation 3 had 8 rabbits. So generation 3 had 8 rabbits. Okay, what I want you to do is I want you to go through and I'm going to ask you then to connect your lines. Draw a line through all the points on your graph. Okay? Let me show up a little bit darker there. All right, so when you're done, you should have a curve that kind of explains what happened to the rabbit population, how many there were over a given amount of time. All right, that leaves finally our title. So remember, we're just simply going to fill in how the IV affects the V. Okay, so you can take your labels from your X and Y axis to create a proper title for this graph. All right, when you're finished, I want you to answer the questions underneath the graph. And part of that includes doing some labeling, okay? And when you're done with the questions, or while you're working on that, I want you to pause the video, okay? When you're done with the questions, there's a couple short videos that I want you to watch about this graph, but don't watch this until after you're done with the questions. When you're done with both the video and the graphs, I want you to have me check your graph, have me check your questions, talk to you a little bit about it, and earn a stamp before you go on to the foxes and you start to make that graph. And that one I want you to try on your own. Okay, so let's talk about these videos. Okay, I wanted to show you two videos that go along with this graph here. The first one is this video of fish in a coral reef. Watch this one for me. Okay, I like this one. This is kind of a real life example about what happened outside on Friday. When there get to be too many organisms, they're simply going to use up a resource. All right, and that's what happened here on this coral reef. All right, here's another one I wanted you to see here. I know Mr. Mulder talked about the human population, so I want to show you a little video here about the human population.
Yeah, now, if you haven't figured it out already, I am a nature and a science filmmaker. I like to go to wild places, but those wild places happen to be shrinking in a large part due to the human population getting bigger and bigger. So when are we going to run out of space? If, and, or when? The world's population. Now, to understand this question, you have to understand a couple of things. First, you have to understand how populations change over time. And specifically then, you'll have to understand it with humans. So before we get into humans, which is kind of a difficult topic to talk about, let's talk about something a little easier to grasp, something I studied, fish. So this is my fish tank. Now, I constructed this whole tank about 2 years ago with these guppies in mind. Now, when I started, I only had 2 guppies. And those 2 guppies had about 6 babies, so it turned into 8 guppies, which means it quadrupled its population. In 6 months, those babies grew up to a point where they could start reproducing. And that means it quadrupled again. In 6 months, it'll quadruple again. So that brings us to where we are right now. And there's a lot of guppies in the thing, and they're starting to fill it up. So what do? Well, I have to worry about the health and happiness of my guppies. They don't have to worry about food because I feed them as much as they want. And they're not going to have to worry about predators because clearly won't let me put a predator in this case. But what I'm concerned about is their waste. They're starting to fill up the water. So I had to get 2 new filtration systems just to make sure that they're healthy and happy. At some stage, though, these guppies are going to fill up the tank, and I'm going to have to get a new tank for them to keep living the way they are right now. Now, in many ways, our Earth is a lot like this fish tank, except we can't just go get a new Earth if we start filling this one up. So, what do we worry about? We worry about water, food, disease, fossil fuels, just to name a few. Now, we are at the stage where we can step back, look at the big picture, think about where we've been and where we're going. Turns out about a month ago, Jonas's grandfather turned 100 years old. Unfortunately, he passed away this week, so this video is a little bit of a tribute to him. We also found out this week that Haley and I are having a new baby. This means we're going to have another little baby. So how will the life of our little baby be different than Jonas's grandfather's? Well, let's see. In 1913, when he was born, we had yet to pass 2 billion people in the world. We hit 2 billion only in 1927, then 3 billion in 1960, 4 billion in 1975, 5 billion in 1987, 6 billion in 1999, and 7 billion in 2011. And by the time our little youngster reaches 12 years old, there'll be 8 billion people on Earth. Now the thing we have to figure out is what is the population going to be when our kids reach 100 years old? Turns out the United Nations had some predictions, and the curves look like this. The high estimate passes 16 billion, and the low tops out at 8 billion. But the question is, when will we run out of space? I couldn't answer it though, and nobody else seems to know either. You see, the best book on the subject, How Many People Can Earth Support, doesn't answer it, nor does it give a guess. So I don't feel so bad leaving you hanging. What are your thoughts on human population growth? Well, leave them in the comments below. And of course, this video is way too short to get to all the topics of human population growth, so you don't even need to tell me that there are a lot of things I did.
Okay, so just like Mr. Mulder talked about on Friday when we were outside, you can see that humans were within about a generation of when we are really going to start to think about when we are going to run out of space, food, and water, all those different resources that we need to survive, because our population is growing so rapidly right now. So just some food for thought. Okay, at this point, I want you to go on and do the, make a graph for your fox. Okay, and when you're done, have me check it.